Similarity of right angle triangle theorem. What does the similarity of right angle triangle theorem tell us? In a right angle triangle, if a perpendicular is drawn to the hypotenuse from the right angle, the two triangles obtained by drawing a perpendicular to the hypotenuse are similar to each other and also to the original triangle. In right angle triangle PQR, okay, in right angle triangle PQR, QS is perpendicular to PR. We get two triangles, namely triangle PSQ and triangle QSR. The theorem states that triangle PQR is similar to triangle PSQ and this is similar to triangle QSR. While writing this, it has to be noted that the vertices are having 1:12 correspondence. Consider these two triangles. If I draw original triangle here, this is triangle PQR and this is triangle PSQ. Angle P and angle P are common angles. Q corresponds to S. So angle P is congruent to angle P, angle Q is congruent to angle S, each being right angle, and angle R is vacant. So angle R corresponds to angle Q. Similarly, if I consider the other triangle, PQR, and the second triangle that I have obtained is QRS. In this case, angle Q is congruent to angle S, each being 90 degrees. Angle R is common. So when I write PQR, it should be QSR because Q and P are vacant. Or angle P and angle Q are the third pair of angles which are congruent. So based on similarity of right angle triangle theorem, we state that if a right angle triangle is given and a perpendicular is drawn to the hypotenuse, then the two triangles so obtained are similar to each other and also to the original triangle. Okay, got it? Now based on this, you are having an important corollary which is called as geometric mean corollary. What does geometric mean corollary tell us? Geometric mean corollary if I write it as GM corollary, it states that in triangle PQR, angle Q is 90, QS is again perpendicular. So square of the perpendicular segment drawn to the hypotenuse divides the hypotenuse into product of the segments into which it is divided. The square of the perpendicular segment drawn to the hypotenuse, square of the perpendicular segment drawn to the hypotenuse divides the hypotenuse into product of the two sides into which it is formed. Now, based on this, let us see some examples. Consider triangle PQR in which length of PS, let us say, is 9, length of SR is 8. Using geometric mean corollary, I will get value of QS. Now in triangle PQR, angle Q is 90 degrees, QS is perpendicular. By geometric mean corollary, I get QS square equals PS into SR. Hence, QS square will be equal to PS is given as 9 and SR is given as 8. 9 multiplied by 8 is 72. Now 72 is not a perfect square. Hence, QS will be equal to square root of 72. Okay, we can simplify. I can write 72 as 36 multiplied by 2. Hence QS is equal to 36 being a perfect square of 6. Root 2 is not a perfect square. It is an irrational number. Let us keep it as it is. Hence QS is equal to 6 root 2. Now based on this, I can also find what is length of PQ as well as length of QR. Okay. See, only one value I have found. I can get remaining two values. In right triangle PSQ, in right angle triangle PSQ, this is a right angle triangle PSQ. PQ is hypotenuse, hence PQ square will be equal to PS square plus QS square. This is I get by Pythagoras theorem. Hence PQ, PS square. PS is 9, so it is 9 square. Already we have found value of QS square. I will be directly substituting it. 9 square is 81 plus 72. This will give me 153. That is PQ square is equal to 153. Now PQ will be equal to square root of 153, which is equal to, if I simplify 153, 153, 3 5s are 15, 3 1s are 3, 3 17s are 51. So 3 3s are 9. I can write it as 9 by 17. Hence PQ will now be equal to 9 being a perfect square of 3. I can write it as 3 root 17. So based on these two values, I have found QS, I have found PQ. I can also now find QR using the same method. Let us see how to find. In right angle triangle QSR, hypotenuse is QR. QR square is equal to QS square plus SR square. We have found how much is QS. QS is 6 root 2. So it is it is 72 plus SR is given as 8 square. Hence 72 plus 8 square is 64. Will give me value of QR square, which is 136. Now again 136, let us simplify it. 136 by using tree method. 2 6s are 12, carry over 1 2 8s are 16, 2 3s are 6, 2 4s are 8, 2 17s are. That means 34 is not a perfect square. I can write QR is equal to under root of 136, which gives me 4 into 34. Therefore, QR is equal to 2 root 34. Hence, in a right angle triangle, we can find different values when you know the length of the products. Or if we are given QS and any one side, you can find the remaining sides. Okay, thank you.